Okay, I think we've got it figured out there. Welcome, everyone, to Mark Voids a Warranty. Sorry for the slight delay there. I don't really know what happened. I turned everything off and back on again, and it started working. So, with that, thank you for your patience and thank you for waiting. Before we get started today, I did want to do a little bit of shameless self promotion and talk about Teach Me PCB. This is a new web course that we have ready to go for you folks, and I really do hope you take advantage of it. We're going to teach you how to make a keyboard in this next thing based on the Raspberry Pi Pico, include a couple rotary encoders, teach you how those work, many key switches as you want, a reset power button, throw in a little light sensor so we can adjust the brightness of the LEDs that go on it, and basically, you get a little macro keypad. Can do anything that you want. I mean, here I made a brain because the Teach Me PCB logo is a brain, but it doesn't have to be that. It can be whatever you want it to be. You could make a flight controller, a bunch of switches and stuff for a flight simulator game. You could do pretty much anything. This is the one by Adafruit. I put a fancy knob on there, but basically you use the little rotary encoder to tell it which set of switches that you want these things to be. You of course don't have to do that. There's one by Pimeroni that doesn't even use key switches. It just has these little membrane, well, these aren't really membrane based. I don't know what these are. I have to take it apart again and look at it. But you can do just about anything you want. So if you want to learn more about keyboards and you want to learn, more importantly, how to lay out a printed circuit board, visit Teach Me PCB and sign up today. The course is going to start on the 11th of October, and we're going to give lessons in approximately 2 to 3 hour bites per week to make sure that it can fit in with everybody's schedule. It'll be a little slow for some, hopefully not too fast for most, but if it ever is that you need more time, or the course, the majority of the course needs more time, we can extend things a week. We do not require that you buy anything. Everything is free. So sign up. Yeah. Also, another quick note. I don't really know what happened to the Mark Voids a Warranty hammer. So I did what any self-respecting engineer would do. I went and got a bigger hammer until the other one shows up. So here we've got a nice 3-pound sledge, just in case we need it. Right? I wouldn't use it excessively. No. All right. Well, welcome. Thank you for joining us today. If you have any questions or comments as we go along, the chat is available to you up in the corner there. Feel free to ask. And today's object is a function generator. This thing's, it's not bad. I just have newer, better ones. It doesn't have a particularly high bandwidth. It's 20 megahertz. It's not bad. 2 channels. I mean, it still works. If it can go back together, it'll go back together. But we're going to pop it open and see what's inside. Looks like there's a little USB plug there. So it's just like you would expect on any bench. It's about standard, depth. Looks like it's half rack width. Couple screws on the back seem to be a good place to get started with what's going on. And we'll get going. Something I notice is that this one on the right is already backed partially out. I don't know why. For those of you joining today, Mark Voids a Warranty is devoted to taking things apart. Now, I always say that I'm going to put them back together. I never do. That's just something you're supposed to say. It's like offering to pay for the check, right? Pick up the check at a restaurant. I never win that fight, but you're supposed to play the game. So, on the back of this thing, we've got, well, what do those say? I can't read them. Modulation in. I need a little more light in here. TTL level out A, TTL level out B. So So the first thing off is this little protective bumper that makes this thing so much bigger. And it looks like there's a chassis that might be held apart partially by that. We've got our audience Chester in the back making cat noises. All right. And while you blinked, I was able to get this thing apart. So we get our first look at this. It looks like we've got our power supply in the back and really an interesting transformer design. It looks like they wound a couple coils and put a round, usually you get rectangular transformers around the back. So that's kind of interesting. We've got a serial port. We've got the V-in, and it looks like it's been potted here. All of this we'll get a better look at in a minute. Then over here, this portion of the board looks like it's for control circuitry, and then a couple ICs in sockets. I don't know why those are in those sockets and everything else is soldered to it, but I'm sure they had reason. A bunch of little onboard potentiometers for calibration and adjustment. A couple FFC connectors that go up to the control panel on the front. And that looks to be about it. So, you know, just looking, I don't really know how old this thing is. I can't imagine that old, maybe early 2000s, somewhere in there. Nothing is screaming to me that any of the tech is newer than that. If you happen to know, feel free to say something. Then we've got the B and C connectors on the back end. All right, so we've got a couple things to look at here. Nothing too exciting, but nothing too dull either. So let's go ahead and see if it's not possible to yank this first board. So the first thing I'm going to do is try to scrape away some of this potting material here, which just looks like a little silicone that they're using for detecting whether or not somebody's been into the case. Maybe it provides anti-vibration. I'm not really sure. But I do know I need to get it gone so I can get this ZIF connector loosened. Just need to do that without damaging anything, hopefully. I always like having the ability to put things back together. I never do it, but it's nice knowing you have options. Guess it's kind of like dating that way. All right. There's that connector. Now we've got another board connector. We've got an angry cat in the background. We have all sorts of excitement. He always gets upset during Mark voids a warranty, and I don't know why. Maybe he just feels the world needs to know he exists. Is that it, buddy? Yeah. Okay, so a little 0.1 pitch 2-row 10-pin connector doing something off that front panel. What? I couldn't tell you. I don't see that this one is going to be much of an issue, but we'll see. As we go through, if there are any questions, comments, or concerns that you have, please feel free to ask them. Just going to retrieve my pliers here. Get in there. Come on, big guy. Disconnect the power. And that board, oh, one more here. They used a lot of connectors. I wonder why. Let me get back to a Phillips. That thing did not want to come out. This particular function generator hasn't been plugged in years, so I don't really need to worry about discharging anything. But that could be a concern if you are ever taking apart anything that... let's get another light on here. If you are ever taking apart anything that has been plugged in recently, you do need to worry about electrocution. So what's holding that thing in now? Looks like it might be slotted into the case. So let me pull off one of the sides here and see if that doesn't help loosen things up. Let's see. Whoops. So right now I'm just removing some screws that attach the bottom to the side. I don't really want to pull that bottom part out. I want to release that board. There we go. It's potted into the sides. I couldn't see that from my vantage point. It's just a nice soft rubber. I mean, nothing too fancy to it. And I'm attached with some B and C connectors, so we're going to see what it'll take to remove those safely. Does that plug in? That goes to the B and C on the front. Come here, buddy. Come here. I know, you're a sad kitty. There you go. Okay, now that particular cry. Chester wanted me out of my chair so that he could use it to jump into his. Aren't cats silly? What he wants now, I couldn't tell you. He's been fed, he's been watered. I think he just wants love. There's also the chance that he wants the window open. I put down the blinds when I'm doing mark voids of warranty because otherwise the sun coming in would absolutely overwhelm the lighting conditions. Is that what's upsetting you, buddy? Come here. Yeah, it's a good kitty. It's a silly kitty, but a good kitty. All right, now that we have one of those off, I wonder if... No, I don't have any nut drivers nearby that are big enough. So back to the slow way. So right now I'm just taking a couple of the nuts off of the B and C connectors off the front. So that I can have better access to, I know you can't see where my hand is, but I want better access to that circuit board so that I can have an easier time removing it. What is it, sweet boy? What is it? Oh no. Okay. Let's see what's left. It's almost free. Almost free. I don't really want to remove those because then I have to mark them to figure out where they're going to go back. So let's remove this back base plate after all. A lot of these parts have been soldered in place, especially all of the coaxial cable. So to remove those, the only way to do it is to desolder them. I don't want to resolder them. So I'm just dismantling the case instead. Again, if this had been plugged in at any time, the first thing I would have wanted to have done is to discharge the product first. Okay, so now I've got two brown wires right here. See them? And I don't know which one is which after I unplug them. So I am going to prep a marker and just mark one of them as an index. And these things work great, but they always take a minute to get going the first time. So let's exciting stuff, I know. At least you're not paying any money to watch this. Come on, marker. There it goes. So now that that's working, I am going to disconnect one of those two brown ones, but I'm going to mark it first so that I know exactly where it's going to go back. And there's nothing fancy about it. Just a bunch of white stuff there and on the case in the same spot. Oh, let's go back to a super source there. Oh, wait, is that potted in? Oh, well, that's how I know the difference between the two brown ones. That stinkers. All right. Well, then. They are not making my life easy, are they? And that is part of... I don't see an easy way to get that out, but we're going to do it anyway. All sorts of fun stuff to look at on this one, I tell ya. Okay. So part of the selector switch is tied in to this IEC connector. But I don't see how that comes out just yet. I do see screws. Oh, I see how now. They're hiding it from me. They knew I was coming, and they said, hey, put it beneath a sticker. All right, so we had our first question, and it's a really good one. It says, all of that space in the function generator, does it help the function generator do anything? That's a really good question, Alex. It does help the function generator look expensive. There's not a whole lot of reason, especially for devices this old, for the manufacturer to work on miniaturization. Most lab equipment of the time is approximately this, 19 inches depth. And if you look here, there's a fan that wasn't, there's a spot for a USB for something that was never installed. So what they did here to save on design costs was they designed a thing that could be used on multiple products, multiple devices, and all have the same basic chassis. So it was cheaper for them to do that than to, make this thing 8 inches shorter for whatever reason. And if it looks bigger, it looks more expensive. It does have some benefits. For example, it'll help with heat. If you don't have stuff crammed into a small area, it's not such a big deal. So all I'm doing right now before I take these off, I'm going to mark these yellow and BL for blue. I can't mark it B because B is also brown. Okay. There's my power connector. Now we're getting closer to where I want to be. Covered in some much heavier potting now. This some sort of a glue. There we go. And we're soldered in. Great. So anyways, that was a good question, Alex. But yeah, they just have multiple products in their test equipment line, and they were making it so that they didn't have to go too crazy there. All right, so we're going to turn on the old soldering iron here. Give that a moment to heat up. I'll heat up the wire and yank it right out. Then we can look at our first board at long last. What else did you want to know? Frequency resonance. It is often a great idea to separate your, while we're waiting for that to heat up, to separate your power electronics from your frequency generation electronics, because a lot of the energy can couple from one into the other. So that does help it some, because those things generally die off with the square or the cube of the distance, but they could have made this thing smaller without much degradation in performance. Okay. See if we're at temperature there. There we go. And you can turn back off. All right. Now, we at least have one board to look at. Let's see what it takes to get to the other one. Looks like it's more the same. You've got a removable rubber bumper. And then a couple screws holding the chassis in. This is a lit power switch, which is kind of neat. There's just a piece of acrylic that is extending the light out to the front, that I guess they could light up if they wanted to. And on the other side, we're going to do the same thing. Okay. Making progress, making progress. Interesting here up front, and I need to give you a closer up view to see it. They went ahead and populated the JTAG to make it nice and easy for whoever put this thing together to program. We've got some unpopulated resistors, caps, and whatnot over there, and an unpopulated FFC cable that does something. Don't know what. Maybe that's the connector for this USB thing out front. If that's the case, it doesn't take much to turn the USB functionality on other than an appropriate connector, and wonder what those are. I haven't seen that land pattern before. That's interesting. All it would take to get that USB going is populating the connectors and the correct firmware. I'm sure it's a two-parter. So, interesting, interesting. Okay, well, we'll take a look at that in just a second. Hopefully it's all removable from the back end. Don't know yet. Okay, so now that we've taken a few things apart, it's time to spin up the microscope, get that prepped, and then we'll take a look at how this thing was put together and assembled. So first thing up, we've got the function generator outs. So these guys, these orange things, I'm trying to figure out precisely what those are, and my knee-jerk reaction is they're relays, but I could be wrong. EA2-5 NEC, and then I can't read that part number without the microscope. But we've got the A and B RF lines. We've got a bunch of digital lines. So if those things were relays, it would make sense that they're doing that to energize and de-energize these things. On the back side, it's not really giving me fuses. They're fuses. Oh, that makes even more sense. But if they are fuses, what's all this support circuitry doing? Maybe just letting us know that the fuse is still good. So if you fuse those, that would make sense. Maybe a resettable fuse. Looks like there's schmutz on here where they had flux and they didn't bother cleaning it off. That does destroy a board over time. The acid in there is still active enough that it can eat through traces, so that's no good. There is a mixture of plated through hole and surface mount parts, which does, I mean, it always increases the costs of a board. If they could have, and I think they could have, if they could have put these parts, wait, no, these guys are clever. They did it so all the soldering's on one side. So even though there was two-sided assembly, it's still single-sided solder. So this could go through a wave reflow. Oh, okay. So usually it's cheaper to put all the parts on one side. But I think what they did here was even more clever. They put all of the soldering on one side. Clever, clever. So that this thing could go through a wave reflow. Interesting, interesting. Okay, so I take it back. They did okay. So they've got a couple RF lines, just coaxial cable that runs off to the back. Everything is connected to nice big fat pads, so it's easy for the assembler to put together. Here you can see that we've got no parts on this side at all, but plenty of soldering. And that might also explain the reason that we have those sockets on the front side. Look at how far apart those things are. These things are like 2.5 millimeter pitch. They're pretty far apart. So if you've got a part that's got a smaller pitch than that, and it might be difficult to put in, or it might be ESD, or maybe they're getting programmed elsewhere and then pushed into the board. Well, then you get these sockets and you just push the part in and, you epoxy it in. So we're seeing, as a general rule, that on the bottom side of the board, traces run up and down. And on the top side of the board, they run left and right, although the designer did make exceptions where they wanted to here. You can see over on the side, they did do some 45s and whatnot. And I think that was just to minimize the via count, maybe. So I'm wondering why they didn't, run that one on the other side. But it's no big deal. It's not a problem at all. Traces and spaces aren't that much of a problem. They did do copper pores all over the place, just to probably help with signal integrity. They were worried about radiating emissions and whatnot. And then I was looking around here, even though we don't even have the microscope out yet, you can see on these copper pores, whenever that the copper got into a smaller area, it looks like they went to the trouble of tying it with a ground pin. That's an excellent idea. But on something such as a function generator, I probably would have been a little more liberal with the placement of those. Put them, okay, so there's one here, maybe put one there too. Maybe put them every 0.2 inches, every 0.1 inches. There is a rule of thumb that you want to drop those things, whatever your... Okay, so I don't want to talk too much about whatever your maximum frequency is, because it confuses people. You tell people what's your max frequency, and what they're thinking is, oh, well, it's 20 megahertz, but it's not. The maximum frequency of your circuit depends on the maximum edge rate of your design. Anyhow, let's move to the microscope, and I wanted to take a look at those vias. So let's flip over, and no, that is certainly the wrong button. There we go. All right. So here I'm seeing quite a bit of drill wander. So you can, whenever you have a via pad, you always want to make it decently big to basically to allow your drill to wander in whatever direction it's going to wander in without breaking out of the pad. Now, granted, IPC Class 2 devices are allowed to break out as much as 90 degrees and still call the board good. But here, where you've got plenty of room, there's really no reason those pads couldn't be another 5 mils, 10 mils in diameter, and everything would still work out just fine, right? You would still have more copper up at the edges. Here it looks like it's broken out a minor bit. I'm gonna have to zoom in there. It's starting to break out. It's just on the edge of breaking out. 10 or 15 degrees. Class 3 device, you still need 2 mils on external pads, 1 mil on internal pads to pass Class 3 status. So these things wouldn't have made Class 3. They're fine for Class 2. But again, what's it going to hurt making that pad a little bit bigger, and then you don't have any breakout at all, right? And that's the case in a lot of these. This one, it is the same as the others. It's just the solder mask partially tinted, so it looks a little Looks a little wonky, but there's nothing special about this one at all. Let me see if I can find it here. Where is the... There we go. So there's nothing special about that one. It's drilled just the same as the others. It just has some schmutz over the top of it. Let's back out, and we'll keep looking around. Anytime you have those copper pores, and those copper pores are a good idea, don't let anybody tell you they're not. I know some people that would. You do want to put vias to tie those things in. Otherwise, these copper planes can end up becoming antennas. And on a device that's designed to create electrical circuits, that can certainly be a problem. Here you can see that the via pad, the pad ring, is really close to the drill diameter. And that is a problem, right? Not much metal around there. And the question is, why? Why do that to yourself? It's a mixture between dip packages and surface mount. All of these dual inline packages. That looks a little questionable. It doesn't have to climb up this back side. It's only got to fill like 1/2 or 3/4, but let's see what that looks like on the other. Oh, it's fine. Yeah. So I'm just looking around, seeing for things that they did that I like and things that I don't like. I like that they did copper pores. I like that they tied those things in all of the places that they did, right? I wouldn't want them to change that at all. But what I would like to see is having that frequency of, that frequency of tie-ins on a function generating device elsewhere on the pad where they could. If you look on the back side, there's not a whole lot going on back here, right? They're just using these to create return paths. That's fine, but connect those coppers so that you don't end up having antenna. That's interesting. Let's see if I can get... Okay, so a couple interesting things. One, if you have a copper pore this small, it is great that you tied it in. But then the question is that doing you anything? And that little island, I don't know that it is. But then the second thing is, what's going on here? Is this really an old school HDI board? And they did such a good job of planarizing, I can't see that via. In which case, maybe there's a lot going on these other layers that I don't know about. That could certainly be the case. I mean, back in the day when resistors were this big, man, oh, life was good. So what you're looking for, and what I bought a new lens to show you, it just hasn't arrived yet, is what a good fillet looks like. And it only has to climb up about 25% up the side of that part, which these things do. You don't need them to climb all the way up. Is that a current sense? That's a fuse. Interesting. Okay. So interesting. All right. Well, time's a ticking. We better flip over and continue our dismantle of the front there if we hope to get to it in time. So let me kick back into a wider view, and we'll see what we can do to knock these things out. In my mess, I am, of course, hiding my screwdriver from myself. Christian, I hope you're not watching because Mark hasn't smashed anything yet. And I know that makes Christian sad. But I did get a much bigger sledgehammer. There's a lot of screws. They were kind of sparse with the other screws. But on this front panel connector, they've not been shy at all about using them. All right. So we've got an LCD display on little FFC with a ZIF socket. So I'm just going to remove that and set it to the side for a minute. Nice big display, like a 2.4 inch or so. And we've got a pretty common way of making inexpensive buttons. So you just take 2 copper traces and you make some fingers, and then on the keypad part, you see this stuff in remote controls pretty commonly because it's a cheap way to do it. You've got rubber, some rubber molded part and just these little conductive pads on the backside. So when you press them down, they create the circuit, and you've got an inexpensive switch. One of the things that I am noticing here, I want to make sure I'm not wrong. I don't see any decoupling capacitors on that one. So over on this IC, you see 1, 2 decoupling capacitors, and those are good. If they were closer, it'd be even better, but I mean, that's probably close enough for the edge rates that this thing saw. Here, it's got 3 decoupling capacitors here. I suspect there's more than just 1 power input pin, though. Well, I guess that's a 4th. You really want these things on every power input pin, not all jammed up into one, unless there is only that 1 power input pin on that IC, in which case it's a poorly designed IC. I don't know that it is. We've got a crystal here feeding this. You'd like to see that a lot closer so that the energy gets transferred without, going through an antenna that is the trace wire. U506 looks like it's got some resistor arrays that are doing something. What? I don't know, but I'm sure it has something to do with those switches. Here we've got the decoupling caps nice and close. That's good. You have copper pores everywhere. Again, good, but you'd like to see the copper ties be a lot more frequent. You never know what is end up going to be being a radiating element on your board. So if you have the copper in there and you've got ties down to the other layers, it won't radiate. So they did copper pores here, none here, probably because they figured it was just going to float, which it would. It would become an antenna, but again, those vias keep that from happening. So, anyhow, I'd still be interested to know if you're a designer out there and you happen to know what U500 and U501 are. I can't recall seeing those land patterns for anything. I don't know what those would be. So if you know, let me know in the comments. I would love to know. All right, all you viewers out there in TV land, do you have any questions that you would like to ask? Because I think we've seen just about everything there is to see in this signal generator. I guess we could look at the rotary encoder, but that'd be about it. Rotary encoders like this one use a reflected binary code so that as you rotate this thing around, only 1 bit flips at a time. There's 2 outputs on this that give off, 1 and 0 logic levels, but only 1 changes at a time. And that is because if you ever did have the situation where 2 needed to change at the same time, unless the wiper in here hit both at exactly the same time. And there's no way to get them to hit exactly at the same time because manufacturing is inherently variable process. You would get false states. Excuse me. It wouldn't really know where it's at. Another thing that I will flip to the microscope to show you that I'm not a big fan of are vias that are inline like these. And I'll tell you why. Drills wander. They will always wander. Always, always, always. And if they wander in the direction of the trace and there's no teardrop or keyhole there, it can absolutely break the net. It can destroy your board, make it become useless. Another thing that you tend not to like to see, what is going on here? Did they forget to put a via there? Did they have one there and they forgot to take it out? This big long thing here, it's a great antenna. Let's see if there's anything on the other side. Looks like there's another one over here. So unless those happen to be, and I can't imagine that they are, unless those happen to be microvias, somebody made a boo-boo. Nope, there's nothing on that other side. This is a nice big fat 2-layer board. They just made a mistake when they were putting stuff down and tearing it back up in their electronic software. There must have been vias there, and then when they went to go route the other side, they had to put those switches there for the keypad, so those vias had to go. And now you've just got these random pieces of copper that are doing nothing. So, all right. Well, with that, I think I'm going to end it. That was kind of not as exciting as I'd hoped, but it was still a thing. Remember, Teach Me PCB. We've got a new course starting. Tell your friends, tell your neighbors, tell your friends' neighbors, and tell your neighbors' friends. Join us over there. Learn how to design printed circuit boards. Should be a lot of fun. I've got a great co-instructor, Jesse Robinson, who really knows his stuff. Makes a lot of cool stuff into gaming. I'm sure he's going to really give us a lot of exciting stuff to talk about over there. And if you have questions, please visit us at aapcb.com. We'd love to answer them. If you ever have any questions for me, I'm mhughes@aapcb.com. All right, folks, have a great weekend. Enjoy the rest of your Friday. I'm Mark, and I'll see you next Friday at noon for Mark Voids a Warranty. Bye.